Okay, so this side is a side of a Jupyter notebook. Okay, and this side is the instructions which we are going to follow. Okay, and let us follow instruction. Okay, this is a Unix console. Okay, and here we are writing a command. We are going to write a command, and those commands will execute. Let's say one of the command is ls command. Okay, ls is going to list the various files and the directories that are there in this file. Okay, so this is an example that we're going to use. Okay, let us take an example. Echo Unix command prints on the standard output whatever argument is passed to it. Okay, so let's say uh, here we write echo, and after that we write something. Okay, hi, how are you? Okay, so it is okay. So fine. Let me just change that. Echo, not Iki, it's echo. See, I've written hello. Okay, I shouldn't have written that exclamation sign. Okay, that means something else. So hello, you have written hello, so hello is printed. So echo is a command which echoes it out everything that you write, except those special characters. Okay, so WC. Okay, so WC is a command that prints the characters, words, and lines out of whatever you type on a standard input. Okay, let's say after this words WC, I write something. Hello there. Okay. Oh, okay, fine. So what you can do is, so you can do something like this, like echo hello world, and then you can give an output of this hello world to WC. Okay, so let's write echo, okay, hello world, and use a pipe symbol and give it to WC. Okay, so it says that you have one line, two words, and 13 characters. Okay, so the first character that you get, first number that you get is a line. This is the words, and these are the characters in it. Okay, and I have already created a file called my file. So I've seen it when I entered a ls. So there's a file called my file. Okay, and if you know how to create a file, then there's a nano command. Okay, you can use vi editor also, you can use nano editor also. What you can do is you can type nano. Okay, then this editor area will be opened up. Okay, you type whatever you want to type. Let's say this is the sample file for hands-on to the map reduce session, then enter another line. Okay, I hope, okay, there's somebody in the waiting room. Okay, I hope you are enjoying the session. Okay, yeah, I've written something. I hope you are enjoying the session. Okay, now I want to save it, so you can press Control X to save it. Okay, so it is Control X to save it. So it is asking, do you want to save this file? Yes, I want to save this file. So what name you want to save the file? So let me say that this is my file 2. Okay, this is my file 2. Now if I say ls again, okay, you will see my file 2 is listed over there, right? So that means a file has been generated. So this is my file 2. Okay, so if you want to see the content of it, okay, so what you need to do is you need to use cat command. So you can use a cat command, right? Cat. Okay, and after that you can write the name of a file like my file 2. There you can see this is the, oh, I wrote a spelling of the, anyway, this is the sample file for hands-on to the MapReduce session. I hope you're enjoying the session. So there are two lines into it, right? So what you can do is you can use cat myfile2, and then you can give an output that is presented on the console to WC. Okay, so it is going to tell you that it contains two lines, there are 20 words in it, and there are 100 characters in this file. Okay, and there is a second command, like when I showed you an example, there was a second command called sed. Okay, so I told you about the cat command. Cat command is used to see an output. I told you about echo command. Echo command is whatever you print it over here will be echoing it out. Okay, and you can pass the output to a WC. Okay, it will do the word count. Okay, not only word count, it will also do the line count, character count. Okay, and the next command in line is in chain is SCD. SCD stands for streaming editor. Okay, it is streaming editor. As for streaming, ED for editor. Okay, okay, and it is used to replace a text with something else in the input. Okay, like I told you when we were talking about this Unix pipeline, I told you that you have to replace that space with a new line. So if you wish to replace something with something else, okay, you can use this SCD. Okay, so SCD is used to replace a text with something else in the input. So it is very similar to the search and replace option, right? You look for a particular thing, you want to replace it. Okay, let's say if I want to replace this DHA with DHE, so you can do that. Okay, using SCD. Features of text editors, right? So you can use regular expressions with SCD. Okay, so here you, whatever you see is you have used an expression kind of thing. This is a regular expression. Okay, so SCD, then you have to specify minus E, just to say that you are, whatever is being followed after that is a regular expression. Okay, so this says that you have to replace spaces and tabs. Okay, with a new line. Okay, so what this space and tab is, this blank thing that you're seeing over here, okay, is a space. Slash t is the tab. Okay, so this whole thing that you're putting it over here, okay, is a regular expression and plus. So let me tell you what it means. So slash t and then space and then this and then this plus. This means one or more occurrences of tab and a space. If you have more tabs or more spaces, okay, then you need to replace it with slash n. Okay, so this is how you write slash n. Slash n is a new line. Okay, replace with slash n. Okay, so regular spaces and tabs with a new line. Essentially, it converts a text into one word per line. Okay, so when you chain cat and SCD, okay, cat will give this kind of output to SCD. SCD will do what? Will replace all these spaces. Like here is a space you find, here is a space you find, here is a space you find. Okay, here is a space you find, here is a space you find, here is a space you find, here is a space you find. So it will replace all these spaces and tabs, okay, into a new line. Okay, so you'll see how when we do this, okay, how this is going to change. It basically prints one word per line from the file. Okay, so this one word per line text can be sent further to command called sort. So once this is converted into this form, let's say this and then this another line is DHA, then sample on the other line, file is on the other line, right? So then you can pass this whole to sort method. Okay, sort command. You don't need to write a code for sort. Sort is already given. Okay, so you can use a pipe symbol for a sort. Okay, and when you can give it to sort, then you can also use the reduction function, which is called unique uniq. Okay, using another pipe. Okay, and there you saw here, like if you just play it for a while and you can see.
The third approach is to use Unix
So here
command
I am
in
pausing it.
pipeline or in chain. Let us first try to understand what does it mean.
Okay, I did not want to play the whole thing. Okay, I think it is already there in the PPT. So let's go back to the presentation. I'm sharing my presentation. I hope now you have understood this whole thing. Okay, so cat command is used to output the content of a file. Here the name of the file is my file. Okay, this is a pipe symbol. The content of a file will go to streaming editor, and in the streaming editor you have found out, you have mentioned that okay, using this regular expression, okay, I want to do particular thing, which is this thing. That means replace a tab and a space. Okay, more than one tab, more than one spaces. Okay, using slash n. Okay, and then whatever is an output to it will be sent to sort. Okay, so we'll be writing this command in this whole so let me just copy it over from this, and then I'll be pasting it there. Then you give it to sort, and after that you give it to unique. Okay, so I'm copying it from here, control C, and I am opening up a new share. Okay, so here I am increasing this area. Okay, okay, session got disconnected. Let me just log in one more time. Okay, yeah, now I'm logged in. So let me see that file is there or not. Yes, there is a my file too. Okay, so I'm copying that file command one more time. Okay, So where is it? Here is it. Control C, and here. So I've, okay. Now you see the output. Okay, it's sorted, right? D comes first, F comes later, then I, then M, then R, then sample, then then this. Okay. So the content is coming from my file. Okay. But I created my file too. Okay. Let's write my file too. And let's see here. Are enjoying file for hands hope I, right? So everything is coming here. So the only thing that is getting repeated is the is being repeated 2 times. Okay, every other word is coming only once. Okay, so let us understand this command one by one. So first of all, we created a file, okay, using nano. Okay, then after using that, we used this file my cat command, my file 2. Okay, so this was the content. Okay, see, the content of the file is not changed into it. Okay, only the output is changed. Okay, output of the program is changed. So this is cat my file 2. This output is being fed to scd. Okay, how? You can use pipe symbol for that. You can use pipe symbol, use scd. Okay, you have to specify regular expression, that's why you wrote capital E. Okay, you wrote s slash, then within the bracket you wrote that what you want to replace. You want to replace slash d, and space also you want to replace. Okay, so have some space, and then one or more occurrences of it. So plus means one or more occurrences. If you want to say 0 or more occurrences, you can replace that plus with star. Star means 0 or more occurrences, plus means one or more occurrences. Okay, and with what you want to replace, with slash n you want to replace. Okay, write slash g at the end and then close it. Okay, and let's see the output of it. Okay, I think I've written something wrong. uh, okay, slash ss
Last square brackets.
last square bracket, yeah, last square bracket should not be there. Yes, this should not be there. Now you see the output. The output of scd is, it replaced every line. So see, this was a text. Okay, so after this there was a space, so that space is, replaced with a new line slash n. Okay, then after is also there was a space, new line, new line, new line. Okay, so new line was entered, isn't it?
So why slash G is written?
Okay, okay, why g is written, okay, I'll tell you later. Okay, but just take it as it is a requirement here, and slash s, and this s also. Okay, take it as a requirement here that it has to be there. So I'll tell you what slash g means, what this s means. Okay, okay, have you understood the output of it?
Yes, sir.
Okay, now this kind of output should be given to sort command. So you want it to be sorted alphabetically, right? At the moment it is not sorted, it is like a text was given with spaces in it. Okay, so every space was converted into new line. Okay, now how would you give it to the unique? Again, you need to use a pipe command. Use a pipe command. Okay, then you need to write what? You need to write unik, right? Unik. No, 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 not unik. You have to sort it out. You have to give sort command to it. Okay, so what was the syntax of a sort command, if you know? And let's see here. Sort minus s,
Yeah, yeah.
1g. Okay, 1g stands for 1 gigabyte. Okay, taking this particular space, 1 gigabyte. Sort minus s, 1 gigabyte. Okay, so sort minus s, 1g. Okay, And then let's see the output. Now this whole thing is sorted. A, E, F, alphabetically it is sorted. Then give this sort output to U and IQ. Okay. And then using a switch called minus C. Okay. So every switch has a meaning to it. Okay. Unix minus C. Okay. Just because of Unix minus C, the frequencies are written. Okay. Before Unix, we saw that before Unix it was only sorted. Okay. Frequencies were not written. Unix is kind of reducer method. Okay. So before Unix, whatever we were doing, okay, it was like mapper method. So from SCD to FCD and sort are doing the map function, and this is doing a reduce function. Okay, and the map, this file is an input to the map. Okay. Now let us go back. So I hope you are able to see this screen.
Yes, sir.
Okay. So what are the problems in approach 2 and approach 3? Approach 2 was SQL and approach 3 is Unix. The moment the data starts going beyond RAM, the time taken starts increasing. Okay, and these are the things which become bottleneck. CPU becomes bottleneck, disk speed becomes bottleneck, disk space becomes bottleneck. Okay, so as long as your data is within the range of RAM, okay, you can successfully use the SQL and Unix. Okay, they will be faster than the programming way, but the point is that they are not able to handle the big data. Okay, then what to do? External sort. External sort is a way out to go beyond the RAM boundaries. Okay, split the files to a size that fits RAM. Let's say some file is more than the size of a RAM. So you have to split the file to a size that fits RAM. Use the previous approaches, 2 or 3, okay, SQL or Unix thing to find frequency. Then you use merge sort, which is like a sort minus M. Okay, sort minus M is like merge function, and sum of the frequencies. Okay, so you have multiple files now, multiple files that fit into RAM size. Okay, and you call the approach number 2, call approach number 3 to all these splits of the files, and then you merge and sum of the frequencies. Okay, that's the thing that approach number 4 says. Okay, use external sort. So machine 1, you give some data to machine 1, give some data to machine 2. Okay, machine 1, let's say machine 1 is 2 GB, having 2 GB of RAM. Machine 2 is also having 2 GB of RAM. You have a data which is of 4 GB of RAM. You give 2 GB of data to machine 1, 2 GB of data to machine 2. Okay, that's the total data was sa re re ga ga re. Okay, so you gave sa re re to this and ga ga re to this. Okay, and who divides the data? It's a launcher program which divides the data, and who gets the output? It's a launcher which gets the output. Okay, and then it is given to a merge. Okay, so launcher acts like a map. Okay, and then this merge command, which is like sort minus M, is like it's working as a reduce. Okay, and merging, if we say how much time merging takes big O of n times, because it has to go through the number of items which are to be merged to merge the sorted data. Data is already sorted. Okay, or the time is proportional to the number of elements to be merged. Okay, how it is already sorted? I mean, merging is only done on the sorted data. Okay, sort command has sorted the data. And minus M, that means you have to merge it also. But the time is proportional to the number of elements to be merged. So we say that number of elements to be merged are n. We generally take n as a number of elements to be merged. Okay, and for more than 2 lists, let's say if you have this kind of a data, you have more than 2 lists, you have 3 lists over here. Okay, you can use min heap as the data structure for merging. Okay, or merge 2 at a time. What you can do, you can merge 2 at a time. This is another approach to merging. So is there any problem with approach number 4? I hope you people are comfortable with the approach number 4, which is the external sort. Distribute the data to multiple machines, take an output from machines, and then merge the data. Okay, what's the problem? Problem is that time is consumed in transportation of data from sending to machine, taking the output of a machine, sending a lot of data to another machine. Let's say you have 4 GB of data. Sending a 2 GB of a data to a machine is going to take a hell lot of time in terms of data processing, right? So for each requirement, we would need to special purpose. We would need a special purpose network oriented program, which is optimized in a way network data is being transported. Would require a lot of engineering in that case. So what is the solution of an external sort? The solution is the map reduce. Okay, now we have appreciated the need of a map reduce. Okay, map reduce is better than external sort. It addresses the efforts, okay, which are addresses the challenges which are faced in external sort. Okay, we have seen 4 ways, and we've seen in all those 3 ways, the 3 ways which were there. Okay, programming way. Then second was, what was the second way? First was programming way, second way was
SQL.
SQL, right? Not, don't call it SQL, it's a SQL. Okay, it pronounce it as SQL. And the third way was uh, Unix pipeline.
Unix type.
Yeah, Unix piping. And the fourth way was external sort. External sort can go beyond the RAM size, but step number 1, step number 2, and step number 3, okay, like way number 1, way number 2, way number 3 are working within the RAM size only. But however, external sort is not powerful because of these limitations. Solution is map reduce. Okay, and we have already discussed what is this map reduce. It's a programming paradigm to help solve big data problems, specifically sorting intensive jobs or discrete intensive. There are 2 codes that you need to write: mapper and reducer. Mapper does what? It converts input into key value pairs. Reducer does what? It aggregates all key values, all the values for the key. Okay, yeah, we have already gone through this, that it can be written in Java. Another thing. Okay, so there are some examples where only mapper is used. Okay, like no reducer is used. You have a directory of profile pictures in HDFS. Let's say some of the profile pictures are stored in machine 1, some of them are stored in machine 2, some of them are stored in machine 3. Okay, so from machine 1, okay, you pass it to mapper. Okay, so mapper will do what? Mapper will convert an image into 100 cross 100 pixel size. Okay, so here it is inflated image. You can say that these are inflated image. Okay, and those inflated images are like 1D array. They are transferred into 1D array. So you can imagine, like, when you pass an image in a neural network also, the first layer is going to get the data in the form of inflated array, 1D array. You have to convert that into 1D array. But a mapper function over here is doing the opposite. Okay, mapper function is taking the 1D array of a data into 100 cross 100 pixel. Similarly, machine 2 can also pass to a mapper function, okay, which can also take an image, convert every image into 100 cross 100 pixel. Okay, machine 3 also sends the output to a mapper function. Then the output of these mappers can be stored in HDFS, output directory of 100 cross 100 pixels. Okay, profile pictures. Okay, so this way you can think of only mapper situation, where you only use a mapper situation. Okay, and this is like only mapper. You have a data node. We talked about in terms of data node and a name node when we discussed that Apache Zookeeper, when we discussed the other techniques. Some components of Hadoop ecosystem. Okay, data node contains the actual data. Okay, HDFC blocks are there. Let's say there is one particular data node and there is one particular HDFC block 1. Okay, the data is stored in an input format. Okay, and most generally that input format is a text input format. Okay, so it is split into records: record 1, record 2, record 3. Like we just took an example, the hands-on that I showed you. You created a file called myfile2 that was containing 2 or 3 lines. Okay, then we replaced every space with a new line. So every line is a record in that case: record 1, record 2, record 3. So you applied a map function to it. Okay, like in the earlier earlier example also. So this data, which is like one record, you give it to a mapper. Mapper will convert, okay, into 100 cross 100. And here also you saw record one can be applied, okay, onto the map function. Record 2 can also be applied to the map function. Record 3 also can be applied to map function. Okay, and the result of the map is key value, key value, key value. Okay, some of the map might not generate anything. Okay, but some of the maps are like here in this map. Suppose this record 2 is an empty record, and if it is an empty record, map is also going to output an empty thing. Okay, and record 1 is containing something. Let's say it has two, two keys, two values corresponding to that. So the mapper will identify that this is a key, this is a value, this is a key, this is a value. And let's say record 3 is only talking about only one key and a value, just an example, right? So this is an output of a mapper. Okay, now here a reducer also. When a reducer also comes into picture, what you have got here as an output of a mapper, you can pass this to a reducer. Okay, so you have passed it to reducer merges it, okay, and makes one part, and you can store that into HDFS. Okay, and here the word frequency problem if we talk about. So on an HDFS cluster, okay, in one particular data node, just imagine you have this kind of a file which contains sare saga. Okay, this is the data. Okay, and you pass it to a function called mapper. Okay, there are two lines, one line and second line. Okay, you pass this data to a function called mapper. For each word, for each, it called for each. Okay, the code is written in a Python language. Okay, if you're comfortable in Python, then it will not be any difficulty for you people. For each word in line, okay, print that word and then one. So this is one, this is not a pipe symbol. Okay, print word and after that one. It's like, so every word, like sa is a word, re is a word, and then again in the new line, sa is a word, ga is a word. So sa, re, sa, ga will be printed with sa 1, re 1, sa 1, ga 1. Okay, so it is just created this kind of output. Mapper output is like sa 1, re 1, sa 1, ga 1. Okay, reducer output will be like this. Reducer will be sa 2, re 1, okay, then ga 1. Okay, so we'll say sa, fine, this is a key sa. Is there any other place where this key is repeating? Yes, it is there. So it will add this one and this one. Okay, we'll write 2 over there. We'll do the same thing with ra. We'll search the entire thing with the another ra. There's no other ra. Ray. Okay, there is no other ray. Okay, so ray will be one only. So ga also, it will do the same thing with ga. So that is reducer job. But as far as mapper is concerned, mapper is only going to convert into key value. Key and value is one. Key and value is one. Okay. And when it gives to a reducer, so as long as there is no reducer, let's say there is no reducer, it's only a mapper thing. Then as long as there is no reducer, this is the only output of a mapper. But if it is required to pass this data to a reducer, then you have to make a change into this output, and this output changes this. Okay, it will be like you sort it out. Okay, you have to apply a sort method to it. Okay, sort method is like G comes first, Ray comes next, as Sa comes next, and Sa is repeating 2 times, so you write this Sa in this way. Okay, so Ga, Ray, and Sa. Okay, so this will be like set now. Here they are only individual items. Okay, so in a sorted thing, it will be a set. Okay, and what reducer has to do? Reducer has just to convert this form into something like this form. Take item out of it, okay, and sum. There's only one item in this set, so 1. There's only one item into it, so 1 will be there. There are 2 items, 1 and 1. It will be adding these 2. Okay, 2. So this is the output of a reducer. So mapper will do what? Mapper will do whatever we have asked to do it. Okay, like for each word in a line, okay, convert this word along with the 1 to it. Reducer will do what? Reducer will take 2 parameters, word and then frequency array. So this is frequency array. Like this is frequency array, this is frequency array, this is frequency array. Okay, frequency array 1, frequency array 2, frequency array 3. Okay, for every word there is a frequency array. Return array dot sum frequency array. So array dot sum frequency array is this. This is the output which you're going to get. Like for example, if you have this kind of data, okay, you have temperature, city, and date. Okay, it's a comma separated file, temperature, comma, city, comma, date. Okay, you see 20, comma, NYC, comma, and this is particular date. Okay, so this, there are all lines which consists of the records of this temperature, city, and date. Okay, and you give it to mapper. Mapper will do what? Now here the mapper function is defined. Okay, it will split by comma. Each line will be split by comma. Okay, so wherever you have a comma, okay, you will be splitting a line. So, and what is the output? Output is T, C, and time. Okay, T for temperature. Okay, city is for C. Okay, C for city, and date is for that time. Okay, and this is the output. NYC 20, NYC 20, NYC 21. Okay, so what is this 20? 20 is not a frequency over here, right? So NYC and 20, which is coming over here, temperature. Okay, what is being printed? Printed is only C and T. See, you are getting three values, but you are only interested in C and T. Okay, C is a city and T is a temperature. What is city? In the first line, city is NYC. In the second line, also it is NYC. Third line is NYC, then BLR, then Seattle, then Chicago, then NYC. So all the cities will be printed along with all the time. Temperature, sorry, T is temperature, T is for temperature. Temperatures are being printed. Okay. So before you pass it to reducer, you sort them out. Okay, sort them out and then make a frequency array. Okay, so BLR 23, just because it starts with B, is going to come as the first row. Okay, along with its temperature. Chicago 21, NYC. Okay, NYC then come. NYC is being repeated thrice, 20, 20, and 21, and four times in fact, 26 also. 20, 21, 20, 20, 21, 26, and Seattle is coming only once, that is, and its temperature is 25. Once this data is prepared for the input to reduce, then you can pass it to reduce. Okay, reduce will do what? Reduce will do this job. NYC 26, BLR 23, Seattle 25, and Chicago 21. This kind of output is like, you might say that this kind of output is a weird output. Okay, it should not be like this. It should start with BLR, right? Because this is how you have sorted it out, right? So it should be like BLR 23, Chicago, and then it should be 21, then NYC, then add all of them together. Okay, Seattle, then you should print 25. But here you see something else. Okay, it all depends upon the reducer logic that you have written. Okay. So if you change the reducer logic, if you want this kind of output, you can get this kind of output. If you do not change the reducer logic, okay, if you just take input as it is, so as it is, an output will be printed, but these things will be added. Like 23 will be added to none, 21 will be added to none, 20 plus 20 plus 21 plus 26, okay, will be added. So here it is not being added, it's being taking a maximum value out of it. Okay, here we are not adding them together. Here the problem is compute the maximum temperature. Okay, so see, the formula for this is to find the max of values. Okay, so there's only one item, 23 is the output, 21 is only one output. Here it is 26 out of 20, 20, 21, 26, 26, which is a maximum. So you're getting the maximum value, that is 26. Okay, so it doesn't mean that reducer always adds things up. Okay, so you have to define a logic for reducer depending upon your need. Okay, so here the logic is to find the maximum temperature. It has printed the maximum temperature out of it. So it is analogous to a group by clause. Okay, you can do the same thing using select query, but the problem with the select query is that if you're using a select query, then you cannot think beyond the RAM size. select city, max temperature from table, group by city. Okay, similar. So this is like selection function is like mapper. Okay, and this maximum, you are taking this maximum function is like using a reduce. Okay, and group by also, group by city also. This kind of thing is a reducer job, and this kind of a thing like city and temperature, you are interesting city and temperature only, not a maximum thing. Okay, is a kind of a mapper thing. Okay, you can one-to-one relationship between a SQL query and a mapper and reducer. Like here, in case of a word count problem, okay, select word count star from table group by. Okay, this is like SQL approach, and here it is a mapper for it, and here it is a reducer for it. Okay, so this mapper and this reducer are both equivalent to this select query. But the thing is that the mapper reducer doesn't have that issue which lies with the select query. Okay, so what happens when you have multiple reducers? So this is some kind of a diagram, okay, hypothetical diagram that you can think of when there are multiple reducers. Okay, some of the items can go to one reducer, some of the other items can go to, I mean, rest of the item can go to the other reducer. Okay, let's say this data, okay, is being split into these two records, pink and white, pink, white, pink, white. So all the pink records can be sent to one reducer, all the white records can be sent to other reducer. Okay, and then there will be two sections of the data. Okay, part 0 can come out as a reduction process applied to pink data. Part 1 can come out after applying the reduction process applied onto the white data. Okay, okay, just wait, I'm putting my system on charge because otherwise it will shut down. So I'm just coming back. Yeah, I'm back. So here it says the thing when it is like there are four reducers involved. Okay, reducer 0, reducer 1, reducer 2, reducer 3. And this is how you can manage the records onto reducers. Let's say first part you can, the zeroth part you can assign to reducer 0. Next you can assign to reducer 1, then reducer 2, then reducer 3, and so on and so forth. Then fourth, fifth, sixth, seventh. This is how you can assign. Let's say in total you have 3,204 units are there. Okay, so this way you can distribute the data across reducers. Okay, and key k will go to this reducer. Okay, so there is how would you assign a key to a reducer? You can use some kind of a hash code method. Okay, hash code k, then remainder with total reducers. Okay, so how many reducers are there? There are total 4 reducers are there. Okay, so you just need to know the k key. You apply some hash function to that. Okay, and then have a modulus on to total number of reducers. Okay, so that output only comes out of 0 and 3 only. Okay, so 4 becomes 0, 5 becomes 1, 6 becomes 2, 7 becomes 3. So I hope you're comfortable with the modulo operation, right? Like time also has a 12 modulo. Okay, so if it is 1 o'clock, we say that is 13 o'clock. Like 13 o'clock, we say that it's 1 o'clock. 13 becomes 1. Okay, 14 becomes 2. Okay, 14 is mapped to 2. 15 is mapped to 3, right? So on and so forth. So why do we do write a modulos? Because we know that we only have 4 reducers. Okay, the next job should be assigned to the existing reducer only. That's why we use a modulo thing. Okay, so this is it for the map reduce session. Okay, and you can think of that merging operation. Let's say you have two queues of people. merge the, you want to, let's say this is also a sorted thing, this is also a sorted list, you want to merge these two sorted element, a sorted list. Okay, merge the two sorted queues to form another sorted queue. How would you do that? You can pick up, okay, you can pick up like the smallest from one and smallest from the other, and then you can compare how are they related to each other. Okay, so then compare the heads. Okay, and then you can take this and then you can, you know, pick shorter, compare the heads again. Okay, then you need to do pick both if equal. Let's say in this case both head are equal, so you pick both of them. Okay, and you compare the heads again. Okay, pick shorter one, compare the heads again, pick shorter one, you pick the shorter one, compare the heads again, pick the shorter one. Okay, and then since no one is left on the second queue, put the remaining from the first. Okay, this is how you do merging, and the same principle is applied by the reducer for merging. Okay, the logic, let me just go it one more time. Okay, let's say you have two lists. Okay, you have two lists, okay, of people, and you have to create another list which is again a sorted queue. So you are going to pick up this one and this one, you're going to compare heads. So here, and then you do what? Pick shorter and you place a shorter over here. Okay, here you are making a list, right? Pick shorter. Then you take another element. Okay, another person, compare the heads again. Okay, whosoever is smaller, place it there. Pick shorter. Okay, then again, okay, compare the heads again. Pick both if you are, if so you picked both of them. Okay, pick both if equal. So compare the heads again. Okay, like two people, this people and this person and this person. Okay, pick shorter, and then now this person and this person being compared. Okay, pick the shorter one. Okay, compare head, pick the shorter one, and then since no one is left on the second view, put remaining on from the first. So this is how you do merge. Okay, so let's do a recap what we have learned so far. Now there will be some questions, I'll be asking you questions, right? So the data generated by the mapper is given to reducer is, and then it is sorted.
No.
Okay, no, because the input to a reducer should be a sorted one, right?
Yes, sir.
Yes.
Okay, output of a mapper is first shuffled and sorted and then given to reducer, right? Okay, the mapper can only generate a single key value pair for an input value.
No.
No,
False.
there are multiple key value pairs, right? Can generate as many key value pairs as it wants for an input. Okay, a mapper always have to generate at least a key value pair. Always have to
Wrong.
generate at least a key value pair.
Wrong.
Okay, wrong. By default, there is only one reducer in each case of streaming job.
True.
True. Yeah. By default, there is a single reducer job, but it can be split by specifying CMD option. So note down this command, okay? So I want all of you to note down this command. By using this command, you can split your job to multiple reducers. Okay, map red means it's a map reduce dot reduce job dot reduce dot tasks. Okay, and when in the next class we are going to do a hands-on, we will see how this command works, what are the parameters to it. Okay, and how we can reduce a single job into multiple jobs, and how we can give it to multiple reducers. Okay, so in Hadoop 1.0, what is the role of job tracker? There are two roles: executing the MapReduce logic or delegate the MapReduce logic to task tracker. We're talking about job tracker, right? We're not talking about task tracker. So job tracker was like a manager, right? So manager is used to delegate the task to the task tracker, isn't it? So
Yes,
manager
sir.
doesn't do the job, right? So it has to be B, right?
Yes, sir.
Okay. The map logic is executed preferably on the nodes that have the required data. Yes or no? Map is to be done on the data, right? Okay.
Yes, sir.
Okay. Yes. The map logic is always executed in the nodes that have the required data. It's like always is important here. No. So you might, there, let's say if you have a metadata, which is a very large metadata, like in case of, data centers, even metadata is also in form of terabytes or petabytes. Now you can think of, so every day we used to, output data. When we click a like on a Facebook or when we tweet something, okay, we generate a data. Okay, we contribute to that big data, right? And for a big data that we generate, okay, there has to be a metadata also. Okay, so if metadata gets increased, okay, so we can also use this map reduce logic or map logic or reduce logic to the metadata as well, right? Metadata is not the actual data, metadata is about the data, right? So
Yes, sir.
so it's wrong that it is always executed on the nodes that have the required data. So where does Hadoop store the result of a reducer? In HDFS or a local file system? Like in the examples that we saw, arrow was protruding out and we were saying HDFS, 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 right? So it has to store into the HDFS. Okay, do you agree with this?
Yes, sir.
Yes, sir.
Okay. So where does Hadoop store the intermediate data such as output of a map tasks? In HDFS or a local file system or a memory?
Memory.
First in memory, okay, and first to local file system. Okay. Output of mapper is saved in HDFS directly only if there is no reduce space. If there is a reduce space, if there is a reduce space, then you have to sort that output of a mapper, right? Otherwise, if there is nothing, if there's nothing like that, then you can store directly the mapper output to the HDFS. You saw that? Like, let me just show you that thing I'm talking about. Like, if there we came across a situation when there was only mapper, right? Uh, okay. Like only mapper. So this is the mapper, right? uh, like here, if there is only mapper, the output directly goes to HDFS. Okay, but in case you have a reducer also, then you have to manage this data and you have to store it in memory. Then you have to purge it to the local file system, and then the output of this reducer goes to HDFS. Okay, and here the output of a mapper, this is a mapper, output of a mapper is not stored in HDFS immediately. It can be directly stored to HDFS if there is no mapper, if there is no reducer. Okay, I hope you have understood.
Yes, sir.
Okay, now let's go back to that question answer session. Yeah, so this is an assignment. Okay, it's written assignment for tomorrow, but you can take this assignment for the next class. Okay, I want you to click a snapshot of this. I want you to do this assignment, frequencies of letters A to Z. Okay, do you need a map reduce for this? Find anagrams in a huge text. An anagram is basically a different arrangement of letters in a word. Okay, anagram does not need have a meaning. For example, if this is an input, the cat act in tic tac toe. Okay, output should be cat tac act the toy in tick. Like you have this one word cat. Anagrams are like alternate arrangements of this tag and act. Doesn't mean that it doesn't necessarily mean to have a meaning. Let's say tag. If you say, you might think that tag doesn't have a meaning. How can it be a word? But here we are not looking for meaning. We're just looking for anagram. Okay. Like the also you can think of EHT. Okay, HET. Okay. And this is another assignment. A file contains a DNA sequence of people. Find all the people who have same DNA. Okay, let's say here this is a kind of a file. User 1 DNA is ACGT. User 2 DNA is TGCA. User 3 DNA is ACG. User 4 DNA is ACGT. User 5 this is the DNA. User 6 this is the DNA. And output is like user 1 and user 4 has the same DNA, right? ACGT and ACGT. So user 1 comma user 4, this has to be output. User 2 doesn't have a DNA matching with any other person, but user 3 and user 5 have a matching DNA. Okay, user 6. So this has to be an output. Okay, I hope you have understood the question. Question is like, you have been given this file. You have to find out what users have the same DNAs and clump them together in the output. Okay. And here, in this case, it is saying a file contains DNA sequence of people. Find all the people who have the same or mirror image of DNA. Now it's also talking about mirror image. Okay. Mirror image in the case, let's say user 1 DNA ACGT, user 2 GNA is DNA. Sorry, user 2 DNA is the mirror image of it, like TGCA. If you read it from right to left, TGCA. Okay, so TGCA. User 4 is the same. Okay, user 3 and user 5 are having same DNA. Okay, so this is also another assignment. Okay, one of the other assignment is, in an unusual democracy, everyone is not equal. The vote count is a function of worth of a voter. Though everyone is voting for each other, as example, if A is a word of 5 and B is a word of 1, are voting for C. Okay, the vote count of C would be 6. Okay, you are given a list of people with their value of vote. You're also given another list describing who voted for who all. Find out what is the vote count of everyone. Let's say you have given two lists. So in this case, voter and this is votee. Okay. A has voted for C, B has voted for C, okay, and C has voted for F. Okay. And list 2 says that this A is a person of 5 votes. Okay, B is a person of 1 vote. C is a person of 11 votes. Okay. No, this is the result. Person and vote count. Okay. A, okay, vote count is 0. B, vote count is 0. C, vote count is 6. F, vote count is 11. Okay, take it as an assignment. Okay. And this is something that you can skip out because we have already gone through the job tracker thing, job tracker, task tracker. Okay, so you can. So what I'm doing is I'm sharing this file with you. Okay. Rest of the thing we will do in the next class. And also tell you that somebody asked that what is the meaning of that /G and /S. Okay, so I'll soon put the answer on our WhatsApp group. So let me share this file with you people. I hope you have enjoyed today's session.
Yes, sir.
Yes, sir.
Okay, just wait for that uh, file. I'm just uploading it so that you can look at the assignment and do the assignment. And if solution, preferably solution, I would like if it is in Python. Yeah, you can download the file. Okay, I have uploaded it. I hope you people have received it.
Yes, sir.
Yeah, download it. And sir, Jagmohan sir, this is it from my side.
Thank you, sir. It was really a wonderful session today.
Thank you,
I
sir.
think students must have enjoyed it. ये इन्होंने mud sort वगैरह कुछ किया भी हुआ है, कुछ something related to that ही था इनका.
Yes.
और अच्छे से मुझे लगता है ये understand भी कर गए होंगे बच्चे. तो let's hope for the best कि ये अपनी assignment कर लें कल.
Yes, sir. अभी next class
तो
हमारी कल तो
tomorrow we
छुट्टी है
will
ना?
be
No, no,
हाँ
tomorrow is
next
a
class वही
Sunday
मैं
ना?
पूछने लगा.
Sunday तो
Tomorrow is a Sunday.
yeah. So next class हमारी वही Tuesday को ही होगी मेरे ख्याल में.
Okay, perfect है sir. ठीक है जी.